question answering is a central problem in natural language processing. With larger and larger pre-trained language models, we see higher and higher performance on question answering benchmarks like Trivia QA and natural questions. They are accurate, yes, but there are other dimensions to measuring the skill in question answering. For example, there is efficiency. How much information do you need to answer the question? There is calibration, the ability to know when you're uncertain or wrong. There's sensitivity to subtle language cues, the ability to resolve conflicting evidence, and the ability to provide explanation. These dimensions beyond accuracy are largely ignored in traditional benchmarks. And evidence suggests that computers are not necessarily as good as humans on these dimensions. But that's not a bad thing. Having complementary skills means there's a chance that we can combine the strengths of machine learning models and humans, and as a result, augment humans to be better at this task. And specifically in Quiz Bowl, a competitive question answering game, many of these dimensions are evaluated explicitly, making Quiz Bowl an ideal testbed for human-computer collaboration. A Quiz Bowl question can be interrupted, so it's not just getting the question right, but trying to answer before your opponent. We built an interface where people can play Quiz Bowl online against each other, just like how they do in real life. But now their teammate is a machine learning model trying to guess the answer to the question. In addition to the prediction, we also show the model's confidence scores, a feature attribution explanation, and example attribution explanation. Our previous work showed that these explanations can indeed make humans better Quiz Bowl players. But we also see that not all explanations are equally informative, and there's a big variance between individuals. Some players benefit more from knowing how the model solved the problem. Some players benefit more from external evidence. So to provide the best possible support, we need to adapt. We need to explain selectively. But how do we know which one to select? Well, we can learn from feedback. While the player interacts with the system, we can record how they perform under each condition and try to optimize their score. There's a trade-off between exploring new configurations and sticking to ones that prove to work. We model this trade-off using multi-armed bandit. User study validates that explaining selectively indeed gives you the best performance, and in particular outperforming showing all the explanations together. For more information, please check out our paper on the website using the link on the screen or in the description. Thank you.